Hi class, let's take a look at question 14. Now, question 14 is asking if the functions are one-to-one and then to provide a justification. Now, for the one-to-one functions, we have to remember the horizontal line test. And what you're looking here is a test that is actually performed on functions. The main idea is that for some x value, you don't have the same y values. So all you have to do is draw a horizontal line and show that it only has one intersection. Here, an x to the second will have technically two intersections, so it fails the horizontal line test, and then it happens to be not one-to-one. So once again, let's take a look at one problem. Here you have a horizontal line, and all you need to do is draw the horizontal line. Don't forget the arrows. And at this point, we're testing if the function happens to be one-to-one. In this case, yes, it passes the horizontal line test, and then you only have one intersection. You only have to show one intersection or if it fails. So for instance, if we take a look at problem B, in problem B, you have a parabola, and it technically is a function, but not one-to-one because it fails the horizontal line test. So at these 2 points, you have the same y, therefore it fails. That means that if you draw a horizontal line, you're going to have multiple places where your actual y values are the same. So in this case, no, the function does not pass the horizontal line test. You only have to find one coordinate point, well, actually one y coordinate point that for multiple x's have the same value. In this case, if you pick x is equal to 1 and -1, they have the same y value. So in this case, this function is not one-to-one. We found one place where the horizontal line test fails. The last one happens to be a cubic. And in this case, well, wherever you move the horizontal line, you're only going to have one intersection. So what we're looking for is in the set of functions, we're checking to make sure that they only have one y value. This concept is going to be used later to find inverses. So in this case, for problem C, it happens to be one-to-one. And you just have to draw or provide a sketch of the cubic function. Don't forget the arrows, and then draw a horizontal line that shows one intersection. You also need some sort of a statement that answers the question. That's actually it for problem 14.